So the ratio test and the nth root test, also just known as the root test, these are the last two tests that we're going to talk about. The last two tests on your worksheet. And people usually really like these tests. So all it is you look at, let's start with the ratio test. You look at the limit as n approaches infinity of the absolute value of the ratio of the n plus first term to the nth term. And if that value is less than 1, then you know that this series converges absolutely, and therefore it converges. So both of these tests give you either absolute convergence, or they give you divergence, or they say it's inconclusive. Okay? And it's all how it relates to 1. If that limit of the absolute value of the ratio is less than 1, for both of these, then you have absolute convergence. If that limit of the ratio of these is greater than 1, then you have divergence. And if it's equal to 1, you throw your hands up in the air and say, I got to use a new test. Okay? So, when do you use this test? When you have a combination of different things. There's some that are like P series, some exponential or geometric series, and especially if you see factorials, which we have not seen a lot of factorials yet, but if you see factorials, then this is when you use this test. And because I've mentioned factorials, have we talked about factorials at all? Have we talked about this, the fact that this is just like a little side note that we're going to use a lot? N plus 1 factorial equals n plus 1 times n factorial. Have we talked about this yet? Not yet? Okay, then put this down under like a note, because we're going to use this a lot. We'll use this as a note, and then we'll explain why this is the case. Yeah?
So for the ratio test, it includes when the limit goes to infinity. So like if the limit goes to infinity, it's kind of it's greater than 1.
For sure. Yeah, if that limit goes to anything greater than 1, including infinity, then we would say that the series diverges. But the cool thing about the ratio and also root tests is that they give absolute convergence. When they give convergence, it's absolute convergence. The alternating series test or the other tests give like convergence, but then you'd have to dig deeper to see whether the absolute value of that converges or diverges, to see whether the whole series converges conditionally or absolutely, or whether it diverges, right? Okay, let's talk about this. Is this intuitive? Like, does that make sense without an explanation, or not really? Not really. Okay, so let's choose. Give me a random positive integer for n. 17. There we go. Okay, so when n is 17, what I'm saying is this: 18 factorial. Let's talk about what factorial means really quick. What does 18 factorial mean? 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2, right? Times 1, okay, fine. You don't need that, obviously. So 18 factorial is just that. Now, what this is saying is that this is equal to 18 times 17 factorial. Let's make sure that isn't that the same exact thing? All that we're doing is we're calling this n plus 1 factorial. We're calling that n factorial, and just n factorial would omit the n plus 1 multiplier. So then you have to multiply by n plus 1 times n factorial. Yeah, 18 factorial is 18 factorial. but it's also known as 18 times 17 factorial. And that's going to come in useful when we talk about.
There's like some problems like where you have factorial or something.
Yeah, so if, for example, if we had like 18 factorial over 17 factorial, then you would call the 18 factorial 18 times 17 factorial, and then cancel out the 17 factorial. And it would just be like 18. Okay? So let's focus on that ratio test first. I'll come back to this once it's time for the root test. Okay, so here we go. Prove that this guy converges. So they already tell us that this converges, right? But we just have to prove it. Well, let's just think about this. Before we go through and apply the ratio test, let's think about this. As n increases, the numerator, you keep multiplying by 2 every time. Right? When n is 1, you have 2 over 1 factorial. And then, when n is 2, the next term would be 2 times 2 over 1 times 2. Right? And when n is 3, it'd be 2 times 2 times 2 over 1 times 2 times 3. So you just multiply by 2 over 3 here. The next one, you still multiply the numerator by 2, but now you're multiplying the denominator by, by 4. And then you're multiplying the numerator by 2 and the denominator by 5. So 2 over 6, 2 over 7, 2 over 8, 2 over 9. Right? So factorials increase way faster than exponential increases. Exponential is what we think of as, oh, that really takes off fast. But compared to factorials, they don't increase nearly as fast as factorials, okay? So, another thing to note, just as like a reminder, or maybe you've never learned it, is by definition, 0 factorial is equal to 1. That's just a by definition thing, so just write that down. Note, another little note. 0 factorial is equal to 1. Okay. So here we go. Let's use the ratio test. So using the ratio test, we get the limit as n approaches infinity of the absolute value of something over something else. So what is the numerator? Look at the ratio test. I'll do this for you. A sub n equals 2 to the n over n factorial. So what goes in the numerator using the ratio test? Two to the n plus 1 over n plus 1 factorial. So what does the ratio test say? Let's go back to that. The ratio test says that I am taking a sub n plus 1 divided by a sub n. Y'all see that? And so if a sub n is 2 to the n over n factorial, what's a sub n plus 1? 2 to the n plus 1 over n plus 1 factorial, right? So then what goes in the denominator of this ratio? 2 to the n over n factorial, which is just a sub n, right? Isn't it a sub n plus 1 divided by a sub n? So it's the red thing divided by the blue thing. right? So now we have to evaluate the limit. And I know how much you guys love limits. So this is awesome. So this ends up being the limit as n approaches infinity of the opposite value of 2 to the n plus 1. Can I write that as 2 times 2 to the n and you'll be alright with it? Isn't it true that 2 to the n plus 1 is equal to 2 to the n times 2 to the first? So that's just 2 times 2 to the n? Yeah? And then, how do you think I'm going to call n plus 1 factorial? Good. And now instead of me dividing by that, I'm going to multiply by the reciprocal because I know I can do that. So times n factorial divided by 2 to the n. So now obviously that n factorial cancels with that n factorial, that 2 to the n cancels with that 2 to the n. And now, let's apply the limit. What's the limit as n approaches infinity of 2 over n plus 1? 0. Which is less than 1. Therefore, the original summation converges absolutely. You might want to say, because they didn't say prove that it's absolutely convergent, they just said prove convergence. But there's a theorem earlier that said if an infinite series converges absolutely, then it also just converges, right? So you might want to say, and therefore converges. You know, pretty cool. Pretty cool. So you see what we did there? That's using the ratio test. Let's do it again. So I'm going to give you a few minutes to work on this one. You're going to tell me if the summation as n goes from 1 to infinity of n squared over 2 to the n. Does this converge? Or does it diverge?